Hey, welcome back. Yesterday we had talked about, started our discussion on statistics and really focused in on a statistical question, and that went along with the collection of data. Remember, in order to gain good statistics on any particular situation, we have to start with a good question. Once again, that's called a statistical question. A statistical question must provide you with a numerical answer and many results. Now, once we have plenty of data via our statistical question, we can begin organizing that data, analyzing that data, and ultimately interpreting the data to make some whatever decisions it is that we need to make. Now, part of after we collect the data is the organizing and the analyzation process. Now, we have some things that I know you guys have talked about previous years, so hopefully you remember them a little bit, and they're called measures of center. What measures of center do is they describe a typical value of a data set. Remember, statistical questions give us a bunch of, or a variety of answers, okay, or numbers. Now, we want, at times in our organization and analyzation process, steps 2 and 3, we want to be able to describe all those numbers with just one number. That's why it's called a measure of center. It describes a typical value out of all the numbers of data that we collect. Now, there's 3 ways to do this. One is the mean, one is called the median, and one is called the mode. Now, what I want to do is I want to focus in on the mean right now. We'll talk about the median and the mode later on. But the mean is also referred to as an average, okay? Now, what I would like to do is I would like to come up with a real life situation, and I want to focus on just one of the centers in the mean, and I want to be able to find what's called the average of problem A. Now, it says calculate the mean of the data set. Now, I have a bunch of numbers here. Think about an example of what these numbers could represent. Go ahead. Okay, maybe you came up with a good example. Maybe you haven't come up with one yet. It looks like there's 1, 2, 3, 4, 5, 6, 7 different pieces of data that I collected once I asked my statistical question. Now, let's go ahead and say that since there's 7 numbers, that those represent the piece of data I collected each day of a week. Let's go ahead and say these are the miles that I ran each day. Sunday I ran 5, Monday 0, Tuesday 10, Wednesday 5, Thursday 7, Friday 3, and then Saturday 5 miles, okay? Now, there's 7 numbers here. Sometimes there's a small group like 7. Sometimes the data that I collect with my statistical question could provide thousands of pieces of data. So what I want to do is I want to pick one number that best describes my data set, okay? I'm going to choose the method called mean, and that's finding my average. Now, how do I find an average? Well, here's what you do. You first find the sum of all the digits in your data set. In this case, it would be 5 plus 0 plus 10 plus 5 plus 7 plus 3 plus 5. And what I'm going to do is divide it by the total number of pieces of data in my data set, which since there's 7 days a week, would be divided by 7. Now, 5, 15, 20, 27, 30, that would be 35 for my numerator, the sum of the miles, divided by the days of the week, which would give me 5. So according to the mean, or the average, I say I jog about 5 miles per day. Okay, that's the number based off of the measure of center that I chose that would best describe this data set. 5 miles per day. Okay? All right. Now, I want to move on to example B. Now, it says calculate the mean of the data set, and what you notice is 6 of the days are exactly the same pieces of data, except the 7th day, which looks like it's Saturday. The number's quite different from the data set in A. Let's take a look. It's 5, 0, 10, 5, 7, 3, and instead of 5, I had 33. So obviously you ran a marathon plus a little bit more, but that's quite a bit of miles to run in one day, but people definitely do it. Now, what I want to show you here is how numbers that are way smaller or way greater than your data set can impact your average or your mean, okay? This is called, a number that's a lot smaller or greater is called an outlier. Notice that 33 really doesn't fit within the range of these other numbers. It's not close to any of the other 6 numbers. So we call this an outlier. Now, let's take a look and see how an outlier impacts my average or the ending mean. 5, 15, 20, 27, 30, plus 33 is 63. Divided by 7 would be 9 miles per day. Now ask yourself, if I ran 5, 0, 10, 5, 7, 3, 33, does 9 miles typically describe, is it a typical value of the data set or the amount of miles that I run per day? Not really. So what does an outlier do? How does the outlier impact that value that I calculate for my average? Well, in this case, since it's a lot higher than all the numbers in the data set, it drives my average or my mean up. It is only, 9 miles a day is only close to pretty much, or gets up to 10 and 33. All the others, 3, 7, 5, 0, and 5, are all below it. So what you have is, when you have an outlier, the mean, one of the 3 measures, the mean probably isn't your best measure of center to use. So you really have to look at, once you collect your data and organize it, when you're organizing and analyzing your data before you ultimately interpret it, you have to make sure that you're choosing the correct center or measure of center. Okay, so in this case, using mean would be a good idea. Here, once you organize and analyze your data, you say, oh, okay, 33 really doesn't fit in this data set, so I better not choose mean. Okay, so you have to, there's times when you want to choose mean, and there's times that you don't. Now, I'll go ahead and let you go ahead and pause the video. Same directions here. Calculate the mean of the data set. Let's go ahead and determine, do I have an outlier or not? Let's look at the pieces of data. 3, 9, 10, 7, 11. Not really. They're kind of clustered together. So go ahead and pause the video. Go ahead and find the mean. All right. But once again, to find the mean or the average, I want to find the sum of the pieces of data in my data set. 3, 12, 22, 29, that would be 40. Divided by how many pieces there are. 1, 2, 3, 4, 5. 40 divided by 5 is 8, whatever it is. It may be the number of laps I took in the pool, okay, over a 5-day period. So that would be 8 laps per day. Now, does 8, pretty good number to describe this data set? Yeah, 8 is pretty close to all the numbers in my data set. All right, so I would say that mean would be a good measure of center to use in this example. All right, if you have any questions, please feel free to contact me. Otherwise, good luck on your assessment.